So I'm Chris McCann. I'm one of the coordinators for SDRuby, and Patrick threatened my life if I wandered back and forth on the stage too much, because the last time I gave a talk, apparently I was out of the camera frame for about half of it. So there's this voice just narrating an empty stage. So I will not do that. I will stay right here, Patrick. Is that good? Okay. So composed of. I remember getting the first Agile web development with Rails book, and there were several sections in that book where the author said, if you're new to Rails or you're just kind of starting to grasp these concepts, you can skip the next section. And there are probably, 6 or 8 sections like that in the book. And this was one of them that I think I skipped over. It was talking about data aggregation. And at the time, when I was just trying to understand Active Record and how Rails worked and how the web app thing worked, I clearly wasn't ready to understand this, so I skipped right over it. And that was about almost 5 years ago. And I was reading Chad Fowler's new Rails recipe book from Pragmatic Programmers, which if you're not familiar with PragProg, it's a great place to go to get Rails and Ruby-related books and a whole lot of different software books, so check it out. Notice the bottom there, pragprog.com. I can give those guys a pitch, because a fair amount of what I'm going to present tonight is taken directly from Chad's recipe about using composed of. And the little byline there says, flat data.convert to rich Ruby object. And that's kind of the idea behind composed of. And even after looking at composed of the first time, I realized I didn't quite grasp how it worked or why you would use it, and decided to get smarter on it, and then had the need to give a talk. So I thought, what a perfect opportunity to try to present what I learned so that other people can maybe use this where it fits in their apps. So let's talk about this thing. So the needs. So you have a simple model attribute that needs additional behavior. Instead of just being a string or an integer or a float or something, you want this thing to have abilities. Maybe you'll call methods on it, do stuff with it. You want to treat it like a first-class object, but at the same time, you don't really want to create an entire active record model with an associated database table and a migration and all the other hoo-ha that goes along with that. You just want to have this thing act like a good Ruby citizen instead of just being a dumb string or some other primitive type. So that's one good use case for this particular macro, as they call it. The other one is if you need to store structured data in a table. A good example is you have a person table and you want to store their name as 3 components, first, middle, and last, or an address, city, street, country, that kind of thing. And you want to store those attributes in with the object that they are describing, but you actually want to be able to treat them, again, as a whole object with behavior and methods and maybe some other more advanced behavior. And you don't want to split out that thing into a separate table. You just want to have this thing easily stored for you, but treat it as a cool Ruby object when you need it. And that's, again, what this is good for. It helps you have an actual normalized first-class object. So let's launch into this. So the first time I saw this, I had to reread this a couple of times. So this is basically the description of composed of. So let's say you have a class, some model, that's an active record model. You can add this composed of thing and give it some attribute as a symbol. Maybe give a class name if the class name that some attribute is not exactly the same as some attribute. So you point that at some special class. It's just a Ruby class. And then you give a mapping. And the mapping took me a little while to figure out. The mapping basically maps the attribute in the model, so in this case some model, to the attribute in this basic Ruby object that you're creating to use in the composed of relationship. And the way it reads, as Chad says, is add some attribute composed of some special class and map some model attribute name field to the special class attribute. Now reading that even a couple of times doesn't tend to make a whole lot of sense. So I have a picture here that I think will make it look a lot more sensible. First, the course record class. This is the one we'll use. This is the example Chad gave. So let's assume you're doing some kind of class and course and grade app. So you have a course record that associates a student with a course, and you can jam their grade in there. And the grade, in this case, is stored in the database in an attribute of the course record class as just a varchar or a string called letter grade. So in this case, we're going to create a composed of relationship or composed of attribute called grade that will basically map that letter grade to a first-class Ruby object. So that mapping thing is, in this case, it's just an array that has the attribute of the class, the active record class's attribute that you're mapping it from. In other words, that's the place in the database where this data will be stored. And then the second half of that mapping array is the attribute in your Ruby class, the composed of class, that's going to allow you to access and manipulate that value. with limitations on the manipulation, which I'll get to. Okay, so here's our grade class. Notice it doesn't say class grade inherits from active record base. It just says class grade. This is just your vanilla PORO, plain old Ruby object, for those of you who are Java programmers. So this is just a basic, simple, fairly dumb Ruby object. The attr accessor there gives you a read-write access to this attribute called letter grade. And you have to define an initialization for this thing, and the composed of macro requires that the initialization take all of the fields in order that you define in that mapping. So you see in the mapping here, we simply have letter grade. Well, that's the only attribute we have to have in the initialization method for this object. And when you initialize it, it will obviously initialize that class attribute letter grade to whatever you pass in. So that's the basics of having one of these grade objects. It's going to manage, and it's going to present itself as the value of the letter grade for the course record class. So let me come back over here. So now here's where you can put all this stuff together. So on the left, you have the course records, effectively the database schema that has an ID and a course ID and a student ID and a letter grade. And then on the top right, you have the grade class, which again is just a plain old Ruby class, much like the one I had on the previous slide. And here's how things map. So class course record obviously maps to this course records table in the database. You have the composed of grade. Grade now is pointing at the class grade, which is just a Ruby class that can live in your model directory if you're doing a standard Rails app. If you wanted to call it something else, if you wanted to call it class grade, and you want then you'd have a composed of with a class name in there to tell it which class it should actually be using for that grade. And finally, the mapping, which if you see on the left-hand side of the mapping after the %W, the letter grade, which is the value that's stored in the database, which is still a normal, accessible attribute of the active record model, in this case, course record. That maps to the letter grade field in the database. And then your other letter grade in the mapping points at the letter grade attribute that you've defined with the attr accessor in grade. So the way this works is if you access CourseRecord.grade, you will not get back the string A or B or C, whatever the grade is that's stored in the database. You'll get back a grade object. And that grade object has a letter grade accessor method, which you could then access, which will hand you the letter grade. So at this point, this may seem like maybe overkill for something that is relatively simple. But let's say that you wanted to give people grades, not just A, B, C, D, and F, but you wanted to give them A+ and A-, B+ and B-. So let me ask you, if I'm going to rank order the students in the class, what's better, an A- or a B? Clearly, A- is a better grade, but if you were to do a simple string comparison between A- and B, guess what? B is better than A-, okay? So that particular comparison doesn't work just with plain old strings. So that's one of the examples of something that you can give capability to your course record that you can't with just using a basic attribute. So things to remember. If you wanted to do what I just described and compare grades one to the next, then you would have to use a comparable, include that in your model, and I'll show you that, and then define the comparison operator in order to compare composed of classes. If you had one course record grade and you wanted to compare it to another, then you would define it like this. So you include a comparable. In this particular case, the sort order is just a hash that has the letter grades along with the minus and plus kind of modifiers associated with an integer value. F and F- basically gets 0, and A+ would get all the way up to whatever the size of that hash is, which is like 1, 2, 3, 4, 5. So I've got two D's in there. There should be a C in there, not two D's. So you can define the sort order for these things, and then define your comparison operator there in the bottom method, which then allows you to compare the grades one to the next, because it's not actually comparing the letter grade, it's comparing the associated number in that hash. And I can give you an example of that. Let me slip over to the code here. All right. So let's say I have a course record. Let me make that bigger so everybody can see. Is that big enough, more or less? All right. Course record.first. Wait, C2 equal course record. Okay. So if I look at the grade, so if I take C1.grade, I get a grade object. If I take that object and ask for its letter grade, I get back a string. If I just take C1 and ask for its letter grade, oddly enough, I get the same thing. But that makes sense, because that's the actual attribute in the active record model, as opposed to accessing it through the composed of relationship. But if I take C1.letterGrade and I ask if that's greater than C2.letterGrade, I get a false. So C1's letter grade in this case is an A minus, and it's not better, if you will, than a B. That's not exactly true. But if I take C1.grade greater than C2.grade, whoops, what did I do? Did I make them A and B? Actually, I guess in this case it does compare them that way. So A is greater than B, and for some reason A minus does come out greater than B. I have to remember what I did for my example to actually make that not be the case. If I say let's try this, A plus greater than A minus, false. So there's a case. So if the grades were actually A plus and A minus, it would say that an A plus was not greater than A minus, because all it's doing under the hood is taking basically the ordinal of that string. So I picked a bad example there since I changed, I think student 2 is Chad Fowler. I changed his grade from A plus to a B. So that's one example of how this relationship can help you out. Let me give you another example. Let's come back to this. The composed of objects are value objects. So if you have this letter grade that you're storing in the grade class, if you want to assign a new grade to the course record object, you can't just change the letter grade in that object. And I'll give you an example of that. So if I take C1 and I change its grade equal to, let's give him a D. I can do it that way. If I do C1.save, though, there we go. So I have an undefined method. Sorry about that. Let's do this. G equals C1.grade. So that grade is a D, which I changed there. But if I then change it, it's supposed to be immutable. Let's see one. Let me just reload that. I feel like Bill Gates. All right, so there is the letter grade. You notice it said it saved it, and it was true, but of course it didn't upgrade the letter grade there, because C1.grade.lettergrade is still an A minus. They're immutable, so if you want to actually assign a new grade, I'd have to say C1.grade equals grade.new with a D. And then C1.save. There we go. Now if I do C1.grade.lettergrade, now I get a D. So there are some cases where we'll actually raise an error because Ruby actually freezes the object internally. So if you try to change it, it will throw an error. I'm not sure why it's not doing that now. Of course, in the practice for this, it did. But case in point, I changed the grade in the associated grade object and then saved it, but the grade still remained an A minus. One of the other examples here is that you have to basically create the new associated object through the composed of relationship in order to save it, and that's what I was just demonstrating. One other case, so if you remember the needs, the second one was if you wanted to store flat data in a database but have a more structured or normalized object, and a great example of that is the address. So you have a person class, you can say it's composed of an address. You can see on the left-hand side that the address, street, city, state, and country are in the database, along with the object that they're an attribute of. And then you could create a composed of relationship, just like we did with the grade, and map in street, city, state, and country. So what that allows you to do is, again, here's the address class, which is really basic. You could define methods like full address down there, and simply take the 4 components of that thing and return them as a string. You find yourself doing this a lot in active record models, especially with people, where you want to show first name space last name, or last name comma first name middle initial, or title and then first name and then last name. And you mostly do that for presentation purposes. There's really generally not a good need business logic-wise to have those relationships, but typically you do that when you want to show them in a view. So you want to show somebody's a list of names and you want it first name or last name, comma, first name. We've all done it. Our code is just littered with all of these kind of helper methods that really don't belong because they're just there for presentation. Well, you can offload those kinds of methods into a separate object without paying the price of having a separate active record model and a database. That also allows you to reuse this. So if you had a person object that had an address and you had a business object, active record object, that had an address, maybe 2 or 3 other models that all have address, well, you can reuse this class address. It's just a simple Ruby class, and the composed of macro will use a copy of that for each one of these active record models that you want to use it in. So the results of this, quick and dirty to the point. Keep your models dry and put the responsibilities and the behavior where they belong. Don't garbage up your models with those kinds of things like full address. You can reuse the composed of models. They're simply plain Ruby objects, so you can reuse them in multiple classes, which also means you don't repeat yourself, which is one of the mantras of Ruby and Rails. You can put all the behavior in one of those classes and reuse it throughout your app. Makes testing easier. I didn't write that down, but clearly if you only have to test it in one place and you know it works, then you're fairly certain it's going to work with all the rest of your models. And the third bullet there is to store structured data flatly, but treat it as a first-class Ruby object. One of the ways that people tend to store things like lists is to serialize them in YAML. And you find yourself, when you're using an object that has a serialized attribute, doing a lot of conversions to and from YAML and having to do basic list manipulations, indexing into the list to get the parts and pieces out of it. And all that stuff really belongs in a separate model. And this is a great way to do that. You could still use a serialized field in your active record model to store the data, but when you actually want to manipulate it, you could do it with one of these composed of models. That last bullet, I already mentioned, we have all these little methods sprinkled throughout our code. It's nice to shunt those off somewhere where we don't have to look at them, and we don't have to put them in every single one of the models where we need that kind of behavior if the need is the same across multiple models for names or addresses or email addresses and that kind of thing. And that's really about it. That's the basics of a composed of relationship. Anybody have any questions? Yeah, Garen.
That was really good. Thank you. I'd completely forgotten all about this, and actually it might be useful. I've been using a feature in Postgres called HStore that lets you store basically an associative array in a field. So this might be a great way of handling that. My feeling is there's a set dirty in Rails, isn't there? Would that be another way of handling if you change the value without creating a new instance?
Well, there's no relationship between the composed of model that points back at its active record parent, if you will, the containing object. There is no pointer between those two. So it's really kind of a one-way street. So if you wanted to change the letter grade in the grade object, you're saying you would then use the set dirty to set the active record model dirty? Is that what you're suggesting?
I'm guessing that if you do set dirty and then the name of the virtual, like the composed of thing, that it might then restore the... I don't know. You'd have to try it, but it would seem like a sensible thing for it to do to me.
Yeah, well, I think
set dirty, is that
it might.
I'm
not sure how that works, how that goes back, because Ruby internally makes those immutable. So I'm not sure how the method chaining would work if it would actually set the dirty on the actual containing parent active record model. Something to try.
But that was good. Thanks.
Yeah, thanks for talking about this. I love composed of. I think it's one of those things that a lot of people kind of skip over and never consider. But with the immutability, I've run into problems myself with just if you forget about the fact that it's immutable and you try to set it, and then it doesn't always blow up at you, but it can cause problems in your app. But one thing that I try to do is in the simple Ruby object that you're using with composed of is never basically never make public any mutators in that. So instead of using adder accessor, use adder reader only.
Sure.
And then if you try to change that attribute, you'll at least get an exception at that time.
Yep.
And I think if you did want to change the whole thing, I think what you have to do is basically instantiate a new object.
Sure.
And set the whole thing.
Exactly.
That.
So that's how I changed the grade to a D. Was I just set the course record.grade equals to grade.new with the letter grade of D.
Right. Yeah. Which is kind of, it's a little unfortunate because like if sometimes, if you've got a composer with a lot of mappings, you've got to sort of recreate them, and if you want to change one little attribute, but it is a consequence of the immutability of that.
Yeah. You can actually use that compositive relationship in searches. So you could you could use it as a condition in a where clause in a finder method. One thing you can't do, at least one thing I couldn't figure out how to do, was try to retrieve all the models that have a specific grade, for example. Or you can't use it as to order things. So you couldn't print an ordered list of all the students in a course with the grade, starting with the A pluses and going down to the S, because there's no way to inject the behavior of that thing into basically into your SQL.
Yeah, I'd have to instantiate all the objects first to even do the comparator, right?
Yeah. Any other questions? All right, well, thanks. And since I'm kind of the raffle guy, if you haven't signed, I saw some guys come in late. If you haven't signed the sign-up sheet, John, would you mind passing that back to those guys? Sign the sign-up sheet, and we'll get you into the raffle. So, Rob, you're now going to talk about debugging. Thanks.